Williams.
And I'm Billy Thomas.
And welcome to another edition of From the Woods Today. We have some new guests on.
Yay! I know, but always exciting to get a first timer. Yes.
And an older guest that is awesome.
Our resident entomologist. Although he might be. We'll have to see how things shake out here in a little bit. Yeah, we're really excited to have you all with us today. Thanks so much for taking some time out of your schedule. Whether you're joining us live or you're catching us on the podcast or via YouTube, we're delighted to have you all with us. We've got two presenters today. We're going to be talking all about kind of insects, right? It's an insect day. It really is.
I've always wondered. It's like, okay, they used to talk about, oh, we get these really cold temperatures, and it'll kill them all out. It's like, well, if we get really hot temperatures, does it kill them all out?
You would think. I know it feels like it smothers me out there.
So does it smother them? Well, he's going to let us know.
Yeah, so we're going to do some myth busting, perhaps. Dr. Jonathan Larson, our resident entomologist that we've had. However, we've got another entomologist today. Yes. There's a new extension professor in veterinarian entomology here at UK, Dr. Hannah Tiffin, and we're so excited to have her on. And she's going to be talking about how we can kind of maybe protect ourselves when we're out and about from some of those things that might cause us some discomfort when we're out there, doing
usually
our thing in the woods.
Ticks, mosquitoes, all those ones that you don't want.
Yeah, so really excited to have both of our entomologists on today, talking about something that a lot of us deal with on a regular basis, right? If you are out and about in Kentucky and you're out in the woods or in the fields, you're going to be encountering these things. So understanding what's going on with them and what you can do to protect yourselves, really important.
It really, really is. So
yep.
Go ahead and get them on.
I know. I was going to say, folks, if you do have questions for our presenters, you can hit them up via the chat function, or you can email us at forestry.extension@uky.edu and we get a response to you that way. But let's go ahead and get the show rolling.
Dr. Larson, if you'd like to join us, welcome to the show.
Greetings.
Hello.
Glad to have you back with us as always. You do such a great job, Dr. Larson.
Yeah.
Well, let's hold the applause till the end. We don't know how today's going to go.
I first brought this idea to you. I was like, they're always talking about, if you have real cold winter temperatures, you'll kill the bugs. And I was like, does that work with heat too? And so you were like, well, let me talk about that.
Yeah. Hopefully talk about both of them, right?
Exactly.
Maybe do some double myth busting.
Yeah.
I appreciate any opportunity to talk about insect biology in any fashion whatsoever. So yes, we will go ahead and get rocking and rolling here in a second. I'm revealing all of my slides. So, there we go.
Get you back to the top.
To the top. So I appreciated the invite to do this because, yes, we do get a lot of questions about sort of climate variability and the effects of temperature on insects. I was looking through my archive and I realized that I gave the counterpart version to this talk just a few months ago about how do insects survive the winter. So I went ahead and kind of reused my header image from that. I just changed the mantis from winter to summer mode. Gave her a nice floaty there, like the one that my daughter has. But this is something that intrigues a lot of people. I think that we have this mindset of we're suffering in the summer, we're suffering in the winter. Surely there must be some sort of impact on all these different insects and critters that are out there. And I guess the short version of this talk would be insects survive the summer very well. They don't really encounter a lot of problems. We're not going to get a lot of free pest control with the temperatures that we've been experiencing. But I kind of wanted to unpack why here with you today. And beyond that, I wanted to talk about some worrying trends that we might see in the future if warming continues, if we see even warmer temperatures in the near future. So that's kind of what we're going to talk about as we go through these slides. I wanted to start by just talking about if we look at a comparison of our bodies and then human body versus an insect body, we have to remember that insects do not have a constant temperature like we do. If I made you wake up in a house that was 72 degrees with air conditioning, and then you went outside and you worked for an hour and it was 85 degrees out, and then you took a shower that was 99 degrees, whatever water temperature you've got. If we were to take a thermometer reading of your internal temperature at each of these junctures, it will be within a relatively small range. We should always be somewhere near that 98 degree mark. That's kind of the classic human internal temperature. So no matter what stresses we're experiencing, that stays pretty constant. On the other hand, insects don't have that. Insects don't have an internal temperature. We can use various words to kind of describe this. We could call them cold-blooded. You might call them poikiliothermic. There's a fancy trivia word for you to use at your next party. But it just means that insects are basically the same temperature as whatever they're surrounded by. So if they're sitting in an area that's 80 degrees, the insect's body is 80 degrees. If the insect is in a 102-degree area, the insect is 102 degrees. Now that means if they move around, if they change their location, the temperature will fluctuate as well. It's just an important difference between our body and theirs. And it's one thing that kind of drives this interest in hoping that winter or summer may kill some of these pests off because they are so dependent on that external temperature. Beyond that, I wanted to point out that they also deal with this heat in a very different way. If I took a group of humans and a group of human-sized cicadas and I made them run laps in a gym, the humans would be terrified because of the giant cicadas, first of all, but they would also start sweating as we made them hustle around the gym. We would not see that with the cicadas. And this is due to an interesting sort of external piece of anatomy that we see with insects and their relatives, which we call an exoskeleton. This is a thick layer of wax. It's different types of wax kind of mixed together in these various layers and structures. I won't belabor exactly how an insect's exoskeleton is designed. Suffice to say, it is a very tough external structure that protects them. It means that they basically don't have skin. Their skin is their skeleton, which is very different from us. One thing that the exoskeleton provides is a bit of a suit of armor. It does keep them safe when they fall or when they're attacked. It makes them kind of strong in that regard. It's also there as a way of preventing fluid loss. They're encased in this wax. That means that liquids aren't getting out very easily. Insects don't sweat, they don't transpire those liquids very easily because they want to keep them in there. It means they have to drink less. It means that they can be outside of water, so they don't have to be subservient to an aquatic habitat. It's just very helpful for them in terms of survival, but it does cut off one of the main ways that animals like ourselves cool ourselves out in the heat. We sweat, that water evaporates, sort of lowering the external temperature of your body and keeping you safe. Insects don't have the ability to do that. Again, they are completely dependent on the temperature that's around them. This is a very prone thing. Many people experience exoskeletons with cicada shells. So I kind of showed one here that's in profile, but then also how the adult is pulling themselves out of that last cicada nymph exoskeleton. You can see just how rough it is to get in and out of these things, but it's very helpful in terms of protection. The other thing I'll throw out there is, insects, they don't have a summer pool pass. They don't have an electric fan that they can set up. Any of these tips and tricks that we all use to try and keep cool during the summer. So that does beg the question, why aren't we seeing, big piles of dead bugs every year when we get these weird periods of 95 plus degree temperatures? That seems like it would be fatal. The truth is that insects have been around for a very long time. That's kind of the basic answer to this, is that insects have experienced warmer worlds than this. They have experienced greater temperature highs than we have ever experienced, and they've come through it. Insects are uniquely adapted to be very plastic in their reaction to all these different things. And over the years, over the thousands of years, essentially their biology has adapted to the point that they have summer strategies just like they have overwintering strategies. And one way that we can see that, one way that's kind of evident, I would say, in what surrounds you, the wildlife that's around you, is thinking about growing zones and insect ranges and forest ranges and things that live in specific spots. We do this with the USDA map, right? We say, okay, well, there's this band of this part of the country that tends to stay between these two temperature averages, and then there's a different range right below it. We color the map differently, and we say, okay, this is what can grow here, this is what can grow there, this is what you should avoid planting in this particular area. This also falls down to the sort of the ladder to things like insects. My example here on the left is the range of sort of firefly biodiversity. If we look down south, we have darker green areas where they report somewhere in the neighborhood of 30 some odd to 50 some odd firefly species living there. It's warmer. They're able to diversify more in those spots, and they're able to survive there. The more northwest you go up into Nebraska and Wyoming and Montana, and then into some of the Canadian provinces, the lower biodiversity you see. They're not able to survive the cooler temperatures in those spots. So everything kind of settles out, basically, just like sediment and water. And you get these areas where things can live and cannot live. We see this even with potential distribution of things like spotted lanternfly, other invasive species. We build these maps, which are based on climate models from their native habitat, and then we kind of find the areas in our country that match up most closely with that. So with spotted lanternfly, it seems like Missouri and then Illinois and Indiana and Ohio, they must match up very well with the native range of this insect. Same with kind of the eastern seaboard. These are the spots where we predict this is this insect will do the best. If we look at Kentucky, most of our state is in yellow, so we expect it to do slightly less well here, meaning we'll be on the sort of exterior portion of its range. There's something about Kentucky that it may just not survive very well here. So because of this, we can kind of look around and say, okay, well, they've been here for a long time, or this matches up with their natural native habitat. We can expect them to become established here. This is a northern species or a southern species. This is a temperate species or a tropical species. They're used to the variability of temperature ranges in these spots. We can also see this kind of boiled down to the insect's biology of development. The success that they have in a given region is going to come down to how they develop through it. Insects develop through what we call degree days. I've tried to explain this on the show before. My analogy is to think of, okay, imagine you were given a bucket of red Lego bricks, and they all have 4 pegs on them, and you can stack them, but your instructions say that you can only stack a Lego on top of the last Lego when the average temperature for that day is 75 degrees. If the average temperature is even higher than that, you may get to stack more than 1 Lego for that day. But basically, this is what insects are doing, is as it warms up, as it heats up, they're able to develop faster, and they're able to accumulate these degree days quicker. So they may get 2 or 3 Legos that day. There may be a cooler day, though, where they only get 1 Lego. There may be a very cold day where they don't get any Legos if they don't cross that threshold. So it's just a way of thinking about how they're able to progress through this developmental stages in the egg form, in their immature form, if they have a pupal form, and then even as an adult, how many days are they going to have on planet Earth? And the geographic range that we were referring to before really is dictated by the temperature and then how many of these they're able to complete. How many generations can you go through? You got to go through at least one to live in that area, but maybe you're more successful in that given area. Maybe it's a little bit warmer there and you're able to develop faster and you're able to have even more generations. We can think of some very elastic pest insects like fall armyworm or various sawfly species, which can have 2, 3, 4, 5, 6, 7, 8 generations in a given spot, depending on how long it is warm in that area. So temperature can be very helpful. Temperature can be very restrictive as well, though. There may be areas where they're not able to live because it gets too warm or too cold. We also see this with the degree day thing. I talked about how there's this lower threshold. Maybe there's a day where it's 55 degrees on average, so an insect can't gain a developmental growing day there. There is an upper threshold to this as well, meaning that if it gets too hot, and we kind of sort of average this to either 90 or 95 degrees, if it's the average temperature for that day is 90 or 95 degrees, they don't complete any development that day either. It's too hot for their whatever stage of life that they're in to complete a growing development day. And so they're kind of arrested there as well. We call this stop and go. There's going to be days where you develop, there's going to be days where you don't develop, but it means that you're very reactive. You're able to sort of suffer through whatever it is you're being exposed to. You're probably not going to perish because you're not being exposed to these unhealthy temperatures for long enough periods of time to either freeze you or to boil you. And so you just stop developing, you kind of arrest yourself on that day, and you wait for sunnier days or less sunny days in some cases so that you can keep going and complete that generation that you're a part of. I'm boiling down a lot of really in-depth insect science for you into these kind of little charts, but I think that I hope that this is helpful in imagining how insects are able to survive through this. So the big question at hand is, will these high summer temperatures that we've been going through provide pre-pest control? The short answer is no. Basically, insects are not going to die because it got hot for one part of the summer. Insects have experienced this heat before. Insects that we have today are the results of millennia of adaptations and movements and changes. And so they're used to weird temperatures. They're used to high temperatures. They're used to cold temperatures, and they have strategies to overcome whatever it is that they're being exposed to. The air temperature that we experience, I would also point out, is not the only temperature that exists in the landscape. I looked through some posts online on places like Facebook and people talking about things that they've read, and I saw some other literature, and people will see things like, okay, the lethal limit for this white grub here is 95 degrees. If they're exposed to 95 degrees for a set amount of time, the insect will cook to death. And that is true. That is a fact, that the lethal temperature for them maybe is 95 degrees. But it was 95 degrees a couple of weeks ago outside in the air where we had our thermometer set up. So we know, okay, we can expect to feel that it's around 95 degrees when we walk outside. But that reading is just one snapshot in an overall greater landscape. If you go into other parts of the landscape, it'll be a very different temperature. And I would point out that things like soil are actually a great buffer for something like a white grub. Maybe a white grub would cook at 95 degrees, but do you know where it's not 95 degrees? 5 inches in the soil where they live and feed on turf grass roots and weed roots that are growing out there. It's a very balmy, I don't know, 71 or 72 down there. Just as the sun heats up the top of the soil, it gets nice and warm down there, but it's kind of climate controlled. They're not going to be exposed to these extremes, and so they're not going to cook. There are other places that the insects can hide out. Leaf litter is going to be a very different temperature than the air temperature. Under a log, under a rock, near a body of water, all of these spots that we historically also enjoy. We sit down next to ponds in order to feel cooler. We sit in the shade of a tree in order to feel cooler. Insects know those tricks as well. They're going to go to these spots where they can sense that the temperature is lower and they know that they're going to be able to survive. This is just like the overwintering strategies I've talked about on From the Woods Today before. They have these methods to deal with the heat. My example here is a fall cankerworm. Fall cankerworms are adults in the fall. Their eggs are laid in the spring. They develop throughout the early part of the summer, and then they pupate in the middle part where it's the hottest. Their pupal form will be in a cocoon. It'll be hidden in the soil where they escape those hot temperatures. And then when it cools down, the pupa actually knows it's time to open up and the adult will come out. So they become these cool season pests, quote unquote. Other behavior changes could include they'll switch their foraging period. Insects can sense when it's warm. They don't want to be warm. They're going to go somewhere else. A famous example of this would be ants. If you go out at noon on a day where it's 80 degrees, there's going to be ants all over the place looking for food to take back to the nest. If you go out on a day where it's 97 degrees at noon, the ants are going to be hidden. They're going to be back in the colony waiting until evening when it cools down again so they can go and forage without having to worry about overheating. They have all of these different ways of being able to do this. I will say that there are some caveats to this. If we have dry weather paired with hot weather, then that could cause some problems for insects. Insects that lay their eggs in the soil in particular, there is a certain amount of humidity that is required for those eggs to be able to survive. This is most famous with something like Japanese beetles. They lay their eggs preferentially in our yards that we water or a golf course that we water because it's nice and moist there. Their eggs won't dry out. If they're forced to lay their eggs in unwatered areas, there is the chance that it will become too dry, and that potentially happened this summer even, and those eggs would cook or wrinkle up and die down in the soil, and then you don't get any progeny out of that particular mother. So while hot is not necessarily the problem here, the hotness paired with the dryness, that does end up causing problems for some specific species. The longer view of this, though, is slightly more complicated than what I'm presenting. So I'm gonna dance on some thin ice here and talk about what will happen if warming trends continue. So we're worried about what happens if the planet gets hotter. Overall, we're worried about what's going to happen to people, what's going to happen to some of our coastal areas. There will be cascading effects on things like insects as well, though. If what we have modeled continues to persist, there will be some things that will happen with insects. The big two will probably be new distribution of pest insects. So new pests will be in new areas. There will be the potential for more invasive species. We could be invaded by insects from different parts of the world. And there's the potential for invasive species to do better in a sort of hotter, more disturbed habitat. We will also see new hosts for native pests. New avenues will be opened up to things that we've sort of long assumed feed on these 20 species. But if things warm up and the environment is slightly different, maybe they'll gain access to trees and plants they didn't previously feed on, and they'll be able to adapt and start to feed on them. We may see some of our long-standing pest controls or monitoring tactics start to become obsolete. Things that we've relied on, say, a phenological indicator. We know that when this plant is in bloom, we go out and spray this insecticide to kill this pest. That might change in the future. That timing may no longer line up. We may see more or more often damage, and we'll have harder to predict pest populations. All of these things could possibly come true in the future if things were to continue to warm. I will also throw out that one distinct possibility with climatic variability or with temperature increases is we might just have higher populations of insects to deal with. We've been talking about, are they going to get killed? Is this going to give us free pest control? It might actually do the opposite. The warmer it is, generally the more successful insects tend to be. It could lead to a buggier world overall. The caveat to that, though, is it might actually lead to just a more pesty world, that we might deal with more pest insects. And I'll kind of unpack why that might be here in the next few slides. But we might just have more bugs. In the past, when it was warmer, there were more insects on planet Earth. So maybe their biomass will go up. We might also see things like changes in migration patterns of insects. If a winter is less arduous in a certain area, that becomes new habitat for something to overwinter in. My examples here are fall armyworms, which some of you may have dealt with back in 2021. Some of you may be dealing with some of them even right now. We've also got potato leafhopper. These are pests that overwinter in the deep south, all the way down to the tip of Texas and tip of Florida, typically, are more sort of tropical regions. But if it gets warmer north of those spots, they're going to be able to overwinter further and further north. And that means that they have more and more of an inroad into the rest of the continental United States. It might ease their migration pattern to return to a state like Kentucky the following spring. It'll make it easy for them to fly here. Maybe they'll get here earlier in the year, and we'll deal with more generations of them as pests in this state. We have talked about the winter coldness rarely eliminating whole populations, but that's based on sort of a normal winter. If you have a period of cold and then it gradually warms and you enter summer, that's normal. If you have a period of not so cold and then a period of extreme cold, which we've seen in Kentucky not too long ago, where we've had these snap freezes really late in the winter or really early in the spring, that could cause populations of pests that have started to come out of their overwintering phase. If they're exposed to enough cold temperatures for a set amount of time, it could kill them. This is based on freaky events rather than just the normal winter. So that could create harder to predict pest problems. We may say, oh, normally we're starting to deal with mass chafer adults and grubs right now, but they all got killed by a frost event April 15th that we weren't expecting. And it froze a bunch of them out as they were coming out of their winter diapause. That is something that could happen with climate variability as well. We've also have data that shows that temperature can impact the sex ratios or reproductive capability of insect populations. For some insects like aphids, it's been found that the warmer an area is, the more females are able to be born and survive in that area. So the population goes from male skewed to female skewed earlier in the season. There will be a point where they become asexual and reproduce without males anyway. And that means if there's more females to kind of start that process with, we could have higher aphid populations overall, kind of leading to these explosions in reproductive capability. On the flip side, it's also been discovered that if insect males are warmer than they're used to, their sperm kind of gets less healthy and it doesn't work as well. So they become less reproductively capable themselves. They can recover, their sperm will bounce back. Hopefully that's not too much of a graphic image for all of you. And they can get healthier. And the younger they are, the more they're able to overcome this negative effect. But it is something that could also negatively impact insect populations. And unfortunately, that seems to be more true of things that we would rather have around. The aphids are going to do better, but something that eats the aphids, for example, a lady beetle, they may be negatively impacted because the male sperm is less healthy in this warmer environment. We may also see these kind of weird layers pop up. Instead of impacting the insect directly, we may see wholesale changes in what can grow in an area. So that means insects are going to have to adapt to new food resources, or they're going to move. You can see this projection of what forests will look like in states like Kentucky. So here's what they've been from 1960 to 1990. We've got an oak hickory dominated mix with kind of a strip of maple beech birch through the center part of the state. In the future, they expect this to switch to having more of the oak hickory and maybe some of the oak pine. And that means that we're going to have different insects that we're not used to living in the state and potentially causing damage. The phenology of plants and beneficial predators are also impacted by these climate variability type events. Plants may be blooming earlier. They may be sort of breaking bud earlier. We all have pests that are able to get going earlier, but this doesn't always happen with things that we consider beneficial, like a predaceous bird or a parasitoid wasp. They may not be enjoying the same benefits that these problematic things are. They're experiencing negative results as a result of this climate variability. Natural enemy populations, things like assassin bugs and ground beetles, they don't go through environmental changes as unscathed as pests do. They tend to suffer, actually. They're less adaptive and they recover more slowly than pest insects do. We've already seen this in data from North Carolina State, where they revealed in urban heat islands, areas in cities and towns that are warmer than kind of the surrounding rural habitat, that those trees that are in those areas are developing differently, and pest insects like lecanium scales that live on a willow oak, as we see here, the willow oak is not doing well because these lecanium scales are hatching earlier and they're escaping all of the things that eat them or lay their eggs in them. And they're developing so much more much more quickly than those things that they kind of escape any of the negative effects. They essentially become an unleashed pest. There's nothing keeping them suppressed anymore. And we'll just see those beneficial populations continue to suffer even more because now they're losing out on their main resource. So the heat's hurting them. They can't find their food. We may even see local extinctions of these things, kind of unleashing these pests even further. The pest populations thrive, but these things like a parasitoid wasp and predators, they can't take the heat. And so they're unable to reproduce, or they're slower compared to these pests, these lecanium scales, and we just end up with more problems than we had before. We also may have more stressed plants, leaving them vulnerable to attack. That means that if a plant is stressed due to the heat, there may be a foothold that things like invasive species are able to gain on them. A stressed plant is more attractive to pests. A pest that doesn't have any natural enemies in the area, something like an invasive Japanese beetle or emerald ash borer, the new version of these that would move into an area, they're going to be able to take advantage of these stressed out plants more easily. It'll give them a nice foothold. And they're very adaptive to these perturbations, and they may even sort of outgain the native pests that we might expect to cause a problem in that area. The invasive is going to be able to do an even better job because there's fewer things stopping them in that area. Weirdly, we may also end up dealing with internal invasive species where things that weren't a pest in a specific state before, they start to move into that state due to new temperatures. So there will be habitat range expansion or habitat range changes, something that used to not be able to live in Kentucky, something like an imported fire ant, for example, now can because it's warmer in this state than it used to be. We may also see host shifts for some of these native species. I would point to things that we call polyphagous, so insects that feed on more than one species of plant, and things that overwinter as eggs. They may end up having a competitive advantage over other pests and be able to start feeding on new trees and new shrubs and starting to expand what it is that is sort of on the table for them. My two examples here are bagworms and then eastern tent caterpillar. They both fit the bill for this. They already feed on a lot of different things. They overwinter as an egg in their mom's bag, if you're a bagworm, or as this kind of gummy mass of eggs on twigs. Both of these could gain a competitive advantage. They get started earlier in the season if the winter is warmer, and they're going to outcompete other pests because of that. They're going to have access to more food and access to a longer period of time in the summer. In the future, we may also see more aphids and scale insects. It seems like they thrive in these hotter conditions in the laboratory. And so we expect that to kind of translate to the field. That could have a big impact on urban trees as well as trees out in the forest. And we'll have to contend with that. The bottom line that I'm trying to say here is we're not going to get any free pest control this summer. And further, you should be worried about what hot temperatures mean for the future. My take-home message is basically we're not sure what's going to happen next. We don't know what we're going to see on the other side of these increases in temperature. The apple cart is upset right now, and it's continuing to be upset, basically. And on the other side of these events, we might see more pests, we might see fewer beneficials, we might just see more bugs overall. It's something that we're going to have to figure out kind of as we go. It means that there's a lot of work for entomologists to do, particularly out in forest habitats, to see what's happening and what's changing there. And it will mean, unfortunately, that there will be new problems and new challenges for the future as well. But I appreciate the opportunity to kind of cut through some of this and talk about why we're not going to see more dead bugs this summer, but also why maybe we should be a little concerned about what's going to happen in the future.
Another fascinating presentation.
Exactly. Always. He's always fascinating. That's why I love it. Thank you. I appreciate you being on.
Yeah, so we didn't really get the answer we were going to maybe.
No, I was kind of hoping for,
So,
the heat's
yeah.
going to make him go.
Yeah.
No,
Actually, we're going to get some more.
I know. I was like, we get it hotter, you're going to give me more bugs. That just means I have to have you on more so you can talk about all these bugs that are out there.
Speaking of jobs. Yeah. Oh, yeah, Dr. Larson, thank you so much. We really do appreciate you taking the time to put that together because, we see these all the time when we're out and about, but understanding kind of what's going on is really kind of important. And you've done such a good job over the years helping our viewers kind of take a little peek into a world that we don't know a lot about, right? Many of us don't. I know you know everything about entomology.
I try to,
but most of us don't, right? So we really appreciate what you've done for the program and for our viewers over the years. You've been a great guest and yes, a great educator. Really appreciate you.
I appreciate those compliments. I'm also very excited about your next guest, somebody that we're excited to have on our team in the extension entomology portion of the UK entomology department.
If you want to introduce her, go ahead.
No, I'm going to let you all do that. It's your show, but I just wanted to say I appreciate having the opportunity to be on, but I also appreciate that you're letting our new folks come on as well. So I want to stick around, answer questions at the end, but let's learn about what Dr. Tiffin has brought to the table today.
Excellent. Awesome. Speaking of Dr. Tiffin, if you could join us, we'd love to have you on camera.
Hi there. Can you see?
Welcome.
Yes,
welcome to the show and welcome to UK.
Thank you.
So
I know when I was scheduled here, kept going. Well, wait till I get there.
So it was a long lead time, but I'm excited to be here. Happy to be on the show, and thanks for having me. And thanks for the kind words from all of you guys. I appreciate it. You really building me up here.
And we're really excited, right? And for a long time, Jonathan's helped us a lot, but we're excited to have some additional expertise come into entomology and extension entomology. And could you tell us a little bit about kind of what you're going to be doing here at UK or what your program might kind of be focusing on?
Yeah, definitely. So I'm a medical veterinary entomologist, meaning I study the, pests of critters. So I like to call it critters on critters. This includes, like four-legged animals, wildlife, livestock, but also people. So that's why I'll be talking about some prevention strategies today with people and, humans. But mainly my work will be on animals. So primarily at Kentucky or at UK, it'll be with livestock. So cattle, horses, potentially some poultry pests. So just kind of I'm still figuring out what Kentucky stakeholders most need, and then I'll be here to kind of try to solve some of those pest and parasite problems. My appointment at UK is primarily extension, but I also have some research. So I'm excited to be working with the stakeholders and then hopefully develop some, applied research on solving some of these pest and parasite problems of animals here in Kentucky.
Wow, that's
Wonderful.
very exciting.
Yes.
And I would say, Dr. Tippin, this is please treat this platform, as a way to kind of get your messaging out. If there is research, you need to connect with stakeholders, or get some kind of a heat check on what's going on out there.
Okay, great.
Got a lot of great viewers out there that are very active, and they'll chime in for us. So
Yeah, I've done that with Jonathan several times. I'm like, hey,
yeah,
there's a new bug. Can you talk about it? So and he's a wealth of information.
Yes.
So like, feel free to anytime that you need to get information out
message
to
out.
woodland owners, let us know.
Yeah.
All right, perfect. Appreciate
Well,
that.
we're excited about today's
Today's
segment,
show.
yes, because we're all out and about a lot. Our audience is an outside type of audience for the most part. They like being out there amongst it, but there are some things that can kind of cause us a little discomfort. So
Yeah, just a little.
We talk about those.
yeah, so we'll turn it over to you. But again, welcome to the
Welcome.
show. So glad to have you here on the show and at UK.
Thank you. All right, let me share my screen here. Great. So, like they said earlier, introducing me, I'm Hannah Tippin. I'm new at UK. I'm actually new in Kentucky. I'm originally from Pennsylvania. Spent most of my life in PA, but a little bit of time in Maryland and in Texas as well. So a little bit of Southern roots there, but Kentucky is very new to me. But I'm happy to talk about any kind of pests and parasites that might be bothering people in Kentucky. You can reach out to me anytime. I'll have my email at the end of this slideshow, and then I also have a Facebook group that you can reach out that way as well through the Veterinary Entomology and Parasite Ecology Lab on Facebook. All right. Here we go. So as I mentioned earlier, I'm a veterinary medical entomologist. So that's really just a fancy way of saying that I like to study the pests and parasites or the critters on other critters. So I've been involved with a lot of different types of animal and parasite systems, everything from mange on black bears and coyotes to ticks on bears, mice, and people, bed bugs on chickens, believe it or not. It's a real issue throughout the US, and then ticks, as I'll be talking about more today. So today I'm going to just be focusing on ticks and mosquitoes that are important in Kentucky, and a lot of the strategies that I'll talk about today in preventing tick and mosquito bites, they can be used outside of Kentucky as well. So they're good for use across the US. First, a little background on vector-borne diseases. So I'll be talking about vector-borne diseases or VBDs quite a bit throughout this short presentation. So I just wanted to define those really quick. A vector is any living organism that can transmit a pathogen or a disease-causing agent to another organism, food, or the environment. So essentially, it's any living organism that can move pathogens around. So in today's talk, that'll be mosquitoes and ticks that are moving pathogens around to other living things, so people or animals. And then a vector-borne disease is a disease that can occur because of these vectors moving those diseases around. But not every time you're bitten by a vector do you get a vector-borne disease. That's why it's not about totally removing the possibility that you could get a vector-borne disease, but about reducing risk. So reducing the number of times you get bitten or the length of time that a tick may be feeding on you to reduce your risk of getting a vector-borne disease. Okay. So a lot of people, when they think of vectors, they might think of mosquitoes and think we don't really have that problem in the US. And while it's true that we don't have as many mosquito-borne illnesses in the United States as many other countries, especially in the tropics and subtropics, we have increasing cases of vector-borne disease across the board in the United States. So we had cases from fleas, mosquitoes, and ticks that tripled in a period of 13 years up to 2016 there, primarily due to tick-borne diseases. So while mosquitoes are my closed captions are on, hold on. There we go. All right, so while mosquitoes are the, often called the world's most dangerous animal because they transmit so many different diseases that can cause really high fatality rates, a lot of illness, like malaria, dengue, things like that. Ticks are really the main culprit of vector-borne disease here in the United States. So about 90 to 95% of all vector-borne diseases in the US are transmitted by ticks, with the vast majority of those diseases those vector-borne diseases being Lyme disease. So most of that vector-borne disease burden is Lyme disease, which is transmitted by the black-legged tick, primarily in Northeast, Mid-Atlantic US, but we're also seeing some increasing cases here in Kentucky and in other areas of the United States as well. And so, like Jonathan was talking about earlier, we're seeing a lot of changes in the ranges of the vectors as well as the diseases that they're causing. And this is, due to global climate change, due to changes in where people are living, how they're spending their time, suburban habitats, things like that. So we're seeing a lot of changes in both the vector species, their ranges, and the diseases that that they're involved with. And so I'm just going to put a little plug in 2 weeks. I'll be back on the show and I'll be talking about tick and mosquito behaviors and how we can harness those behaviors for what's called integrated vector management. Essentially, how do we use these behaviors, use the knowledge of these pests, and use them to have control around our homes and our woodlot properties. So I'll be talking about different control mechanisms in 2 weeks. All right. But focusing in on ticks and the more common tick species that are of medical relevance here in Kentucky, we have the American dog tick that's shown on the left here, has the brown body and kind of a white mottled dorsal shield or that back area. And then the the brown dog tick, excuse me, that's second in from the left there. So both of those can transmit the bacteria that causes Rocky Mountain spotted fever. And so that's I wouldn't say it's common in Kentucky, but it's one of the more common tick-borne diseases that we have here. And then next up, we have the Lone Star tick. So she is over towards the right there, and she could transmit a bunch of different diseases, but in Kentucky, the most common ones would be ehrlichiosis. Again, not very common here, but it is increasing in cases. And then alpha-gal syndrome, which we actually talked about earlier on the show, before the show actually got started. And that's also known as red meat allergy, mammalian meat allergy. It's essentially this syndrome that could develop from the bite of the Lone Star tick. It's something in the salivary proteins that she secretes, can then cause an allergic reaction in your immune system to different types of mammalian meat or dairy products. And so we were talking about this earlier, it really can exist on a spectrum, what your allergy may be. And this is becoming more common across the US, but in Kentucky as well. And then lastly, we have Lyme disease. So Lyme disease is not very common in Kentucky, but cases are increasing. And this is transmitted by the black-legged tick, also known as the deer tick. She's shown on the very right there. She has a bright orange body and like a black dorsal shield. So all black on the top there. And then lastly, this is a newcomer, the Asian longhorn tick. So this one is particularly concerning for cattle and cattle producers, but it's kind of a generalist species. So it can feed on a whole variety of animals and also bites people. And this one is an invasive species from outside of the United States, but it's been found in a lot of different states now, including in Kentucky. And one of the reasons it's so concerning is because it's parthenogenic. And this means that the female doesn't need a male in order to reproduce. So you can have one female on a property and she can have eggs, have babies, and you can suddenly have this high infestation. So this can be an issue not only on the property itself, but on any animals that this tick might be latched onto. So it can cause anemia or toxicosis from these really high, severe infestations that can happen really quickly because of this kind of wild ability to be able to reproduce asexually. And then they can also transmit several pathogens of high concern to both cattle and to humans, as well as some other animals. So this is one that the USDA, as well as many other institutions and researchers are keeping an eye on. Okay, so I'll talk a little bit more about behavior in 2 weeks, but I just wanted to show you how Lone Star ticks act a little bit differently. They're known kind of as more aggressive ticks in the tick world. The other ticks that we have in Kentucky, the black-legged tick and the American dog tick, are questers. So they'll stick their little front legs up and they'll wait and look for a host to pass by. or not look for, but detect a host passing by, but they'll be waiting. Whereas Lone Star ticks are active and they're known as hunters. So they'll go out and they'll try to find their hosts. So I'll show you a quick video about that.
Have you ever wondered how fast ticks are? How fast ticks are? We're researchers at Penn State studying ticks, and today we're putting ticks to the test to see which one is the fastest. To begin, let's meet our racers. First up today is going to be the black-legged tick. Black-legged tick, also called the deer tick, is common across the northeastern United States, and most people know it for being able to cause Lyme disease. Next up, let's meet the American dog tick. The American dog tick is found across the eastern United States and can be recognized by that white patterning along its back. And third and finally today, we have the Lone Star tick. The Lone Star tick can be recognized by that large white dot, and it is found in the southern United States and is slowly being found further and further north. All right, enough chatting, let's race. 3, 2, 1, go. And off to an early lead, we have the Lone Star tick. Unlike other ticks, Lone Stars hunt for their prey and are much faster than the other ticks that we have racing today. And just like that, it looks like we have our first place finisher, the Lone Star tick. Moving right over to the back of the pack, we have the black-legged tick. Quick reminder is that repellents work. We added DEET to this track to keep the ticks on course, and as you can see, the ticks never crossed that line. And it looks like now, here we have our second place finisher, the black-legged tick, finishing our course today. So that means coming in last place, we have the American dog tick. The American dog tick is moving a little bit slower, but he's still finishing the course right now in third and final place.
So that just gives you a really brief look at how differently these ticks can move. So you saw that the Lone Star tick, she just shot across the course there. And then the black-legged tick and the American dog tick kind of took their time looking around, seeing what they want to, where they want to move next. We can move on here.
Have you ever?
Oh, there we go. And then hopefully you also notice that those ticks differed in size quite a bit. So some ticks, like the black-legged tick, are quite small even as adults, and they're really the size of a seed. So you can see they're on this poppy seed muffin just to give you some nice fodder for nightmares later. But fortunately for you all in Kentucky, the black-legged tick isn't as common as the larger ticks, the Lone Stars, and the American dog tick, which are pictured here. So you can see that they're a little bit larger than the black-legged tick, but I also wanted to show that there's different life stages to ticks, and so their size can also differ by life stage, with larvae being the smallest. They're the first ones that hatch from the egg, and then you have a nymph, and then the adults, the male and the female. Okay, so that's all well and good, but how do we prevent getting bitten by these guys? So I'll talk about personal protection. This is just one method and one tactic as part of a whole plethora of strategies that are available to prevent bites and to keep yourself safe. But this makes up the base of this prevention pyramid, which I'll talk more about in 2 weeks. And it makes up the base because it's really the most important. So it's the thing that you should think about first. What am I wearing? Where am I going? Am I going out during times of day where there's more ticks or more mosquitoes that might be present, and kind of limiting your activity when there might be higher tick and mosquito activity. So it doesn't mean wearing a suit of armor when you go out, but it does mean, thinking about wearing longer layers. So often wearing long sleeves, long pants. You can wear taller boots, or you can wear socks with your pants tucked into your socks. Spray those with any type of EPA approved repellent, and then, limiting your time in tick risky areas or times of day as possible. And so all of that to say that the best thing to remember with tick and with mosquito prevention, bite prevention, is a good offense is your best defense. So thinking ahead on how you're going to prepare before you go out into potentially mosquito or tick habitat. So wearing light colored clothing, that helps with ticks because then you can see them easier. And then wearing DEET or some type of similar repellent, you can go Google EPA, the Environmental Protection Agency, and they have a really handy tool where you can put in different categories that matter to you and find a repellent that will work for you and your family. There's also treated clothing. You can get clothing that's been pre-treated with a repellent or a repellent beforehand, or you can buy repellent off the shelves and treat clothing yourselves. Just make sure when you do that, you're following the label. And then wearing long sleeves and pants, doing tick checks when you get back from being outdoors, taking a shower to dislodge any ticks that may be on you that haven't bitten yet, and then hot dryers for your clothing so that you kill any ticks that might be on your clothes. All right, and avoiding tick risky areas. So I talked about that a little bit earlier, but what I mean by that is brushy areas, taller grasses, anything that's a little bit more wild. So you can see that in this picture. These are areas where ticks are more likely to be present. Ticks are they can dry out very easily, so they need some kind of moisture. So they need something that will protect their bodies from drying out. And they also, many ticks, like I had mentioned earlier, quest, so they'll climb up some taller brush looking for their host. And then checking for ticks. So ticks, when they attach to you, they're looking for a place that's going to be, kind of protected or safer for them. So these would be darker areas or areas that are, rubbing on clothing as much. So scalp, behind the ears, underarms, groin, belly button, believe it or not, behind the legs, between the toes, and then kind of similar with your dog or other animals, especially between the toes. And then how to remove a tick. So I have a short little video here. Basically, you want to stretch the skin as taut as possible so that you can get a really good handle on the tick, and then you're going to pull as close to the skin as possible and pull straight out. And you want to get as close to the skin as possible because you don't want to be squeezing the abdomen. If you squeeze the abdomen of the tick, there's the possibility that the tick will essentially puke up its guts back into your bloodstream. And that's what you want to avoid, because that's how you get the pathogens in the first place. So get as close to the skin as possible and then pull straight up. And then there's a lot of animal prevention products. I'm not a veterinarian. I suggest, recommend talking to your veterinarian about what will be right for you and your family. But these are really important to not only to keep your pets and animals safe, but also to reduce the risk of your pets bringing any pests or parasites indoors as well. All right, and then quickly onto mosquitoes. We've seen some articles on mosquitoes in the news, or at least I have, but maybe that's because I'm keyed into mosquitoes. I don't know. If you've seen these, I don't want to, stress you out that there's West Nile out there and you're going to get it from every mosquito you come into contact with. That's not the case. What this is showing is that the vector control agencies are doing their jobs, and they are doing a really good job of doing surveillance. They found West Nile virus circulating in some of the mosquito populations, not in people, in mosquitoes. And so they're spraying to try to contain that risk. So they likely found the West Nile virus in Culex mosquitoes. These are often called house mosquitoes. We have the southern house mosquito, the common house mosquito. They're all house mosquitoes. They're typically light brown with very few markings. These are all 3 different species that are shown here. They look pretty similar. I don't expect the common person to be able to differentiate between these. But essentially, these Culex mosquitoes are found throughout the United States, including in Kentucky. They're not very picky. They feed on both people and animals. They can lay their eggs in fresh or stagnant water, artificial, natural areas. And they're the ones that are primarily involved in West Nile virus transmission. And then the Aedes mosquitoes. So these 2 species are also found in Kentucky. They could transmit West Nile virus, a bunch of other viruses I don't even have listed here. Dog heartworm, it's a really important one. It can be pretty common in the southern US, but it is preventable. They transmit many other types of viruses. Surprisingly, they're daytime biters. So most mosquitoes will bite people dusk dawn. These ones are more active during the daytime. They're also container inhabiting mosquitoes, so they can breed in as little as a tablespoon of water, which is a bottle cap. Pretty scary. So Mosquitoes essentially need two things to survive: water and organic material. The water could be stagnant or slow moving. It really depends on the species of mosquito. And then the organic material is to provide kind of safety and coverage for their eggs, as well as nutrition for the immature stages. So that leads me to why it's so important to get rid of any standing water. So there's a saying in mosquito control of tip, toss, treat. Tip out any standing water, toss any trash or debris because that could hold water, and then treat any water that's left. So you can treat standing water using biological controls like fish that'll eat larvae, mosquito larvae, or BTI, or chemicals. And like I mentioned, some species can hatch in less than a tablespoon of water, which is the size of a bottle cap. And so that's why it's so important to get rid of any sources of standing water around your property. So just to really get that across, stagnant water, that's how you have a mosquito party. If you don't want to be hosting a mosquito party, then you need to either remove the water. If you can't remove the water, you can do things to make the water move along more. So you can add aeration to a pond. You can add predators that'll, like fish, that'll help to move the water. That'll also help because they'll be predating the mosquito larvae. And then just to reiterate, a good offense is your best defense. So wearing those long sleeves, long layers, using treatment, and then avoiding outdoor activity during, the most buggy times of day. So avoiding those buggy and tick risky areas, we went over, avoiding areas with stagnant water, trying not to go out and about during or right after flooding events, because that's when you're going to have a lot more mosquitoes. And then brushy areas or high grasses, that's where you're more likely to have ticks. And then times of day with high tick activity, that's typically late morning because it's often too wet for them with morning dew in the early morning, and then too dry for them during the middle of the day. And just remember, tip, toss, treat. So that includes things on your property as well. You can add these little mosquito dunks to bird baths so that you don't have mosquitoes developing in there, cleaning out your gutters so that there's less debris and standing water up there as well. And then one more time, good offense is your best defense. So wearing those protective layers when you go out. If you do want to get ticks ID'd in Kentucky, there are a couple free services that are available to Kentuckians. So the Department of the State Entomologist, that's at the University of Kentucky Department of Entomology, so the department that I'm in, they provide tick identification for any ticks that are found on people as well as domestic animals. Domestic animals, it's typically submitted by veterinary staff, but I believe you could submit it if it's from your dog or cat as well. And I know this link is a little long, but if you just Google UKY tick surveillance, the link will come up. And then this is a little plug for my lab. If you have ticks found on any other animals, so this would be livestock, horses, poultry, wildlife, or large animal pets, as well as any other ectoparasites found on animals, so fleas, keds, lice, you can submit that to my lab. So go to tiffin-lab.com, and then I'll have a submission link for that coming up soon. It's not quite active yet, but it'll be there very soon. All right, and that is it from me. Please feel free to reach out with any questions. Just getting my lab started here, so I would love to hear from you all on what is most important to you from a parasite and pest on animals perspective here in Kentucky.
Awesome.
Very
Thank
good.
you
Yeah.
so much. We appreciate that.
Thank you.
Thanks for having me on.
And there was a lot of engagement here on the chat. People had a number of questions for you. One was about the tick that caused anemia. You mentioned something. And they were wanting. Yeah.
It's around here. Okay. You can still hear me, right?
Yes, ma'am.
Okay, great. That one I was talking about was the Asian longhorn tick. So I don't think there's any cases of it causing anemia in people, just because you would notice it causes anemia because of the high infestation. But it's a big issue in cattle because they're roaming about the pastures, and the tick can reproduce so quickly that you get these really high tick numbers on the cattle really fast. And so that's what can cause the anemia or toxicosis. Essentially, there's so much different toxins coming in from the tick feeding on the animal that the body is like, wow, what is this? And has some really bad effects, and it can actually kill the animal.
I guess, and a little quick follow up to your tip toss treat. On that, there was a question about treating the lawn itself. Is there any value for either ticks and or mosquitoes, like spraying something on grass? And is there any concern about, children or pets on that as well?
Yeah, so there are some treatments available for mosquitoes and for ticks. I believe most, if not all of them, need to be sprayed by a certified pest applicator. And with ticks, the results are a little iffy. It kind of depends on the species of ticks that you have around, how they're coming into the property. So if you have a really large woodlot and you have a bunch of wildlife coming in, the treatment might not help you that much because the wildlife might be coming in closer to the house past the treated zones, because typically you want the zones a little further from the house. With mosquito treatment, that is typically carried out by vector control agencies. And so oftentimes they'll have a number or a link on their website where you can call if, like, say you're doing everything you can on your property, but your neighbor next door has a dump site or has a bunch of tires out, and they're the ones that have, all these mosquitoes, and now they're coming onto your property. You can call vector control, and then they're allowed to go in there and spray. So they can take care of it without you having to. It can be a risky situation sometimes, but you can typically call them and then they'll take care of that problem because it's a public health issue for the entire neighborhood.
And we're a little late on time, but there is one last one we'll sneak in here for you. Somebody was asking about using DE as a kind of a tick control, that diatomaceous earth. One of the problems I've seen with that, though, is it's not rain fast, so it'll break down pretty quick. But I don't know if does it offer some control on ticks as well?
I believe it can. I don't think there's been a whole lot of research into using it as tick control. Generally, when people are looking into tick control, going kind of that route, more natural route, they'll use entomopathic fungi. That there's also some issues with that. It's also difficult with rain events and things like that, and just getting enough of it out there. So I can't think of any studies or pest control agencies that would be using DE, but I could definitely be wrong about that. Jonathan, do you have a better answer on that one?
I know that some homeowners will try to use DE on their own, but as has been mentioned, as soon as it gets wet, it clumps together and it stops working. It would work on a tick that crawled through it, but the likelihood of you putting enough out in the right places to suppress the population, probably not very high.
Right.
Very cool. Oh, very good.
Awesome.
Dr. Tiffin, so glad to have you on the show, and welcome again to From the Woods Today and to UK. And we'll look forward to having you in a couple of weeks. So folks, if you have additional questions, be stockpiling those, and we'll have Dr. Tiffin live again in a couple of weeks. And Dr. Larson, as always, we appreciate what you've done for the program, for our viewers for years. So thank you both.
So
yeah, thank you for putting us together here too. It was
a dynamic duo, right? Excellent, good stuff. Really appreciate y'all, and we'll have you obviously back on in 2 weeks.
Yes,
but
definitely.
I'm sure we'll see Dr. Larson before too long as well.
No doubt.
All right. Thanks a lot.
Great. See you all.
Yep. Wow, Renee, a really good show, right?
Yes, exactly.
It turned out really well. We had a great new presenter, first timer, and then our resident entomologist, Dr. Larson. So it was good. Appreciate your engagement, folks. Again, if you had any questions you didn't get addressed to Dr. Tiffin, she will be back in 2 weeks. So you can check her out then. And you can hit us up at forestry.extension@uky.edu if you have other questions. We'll try to address them. But Renee, another good show.
Definitely. So I guess that's all for today. We are a little over.
Yep.
So we will see you all next week. Take care.
Take care, everyone.
Bye.
From the woods today. From the woods today.